Rationalizing denominators. Rationalize the following radicals. Let's start with example A. We have 1 over square root of A. So we wanted to rationalize this denominator because here what we see is a radical A, so it's irrational value, and we want to convert this into a rational value. So what we have to do here, because we have a square root of A and we know from the rules of the radicals, if we multiply square root of A with square root of A, we are going to get A square, and then square the power 2 is going to be simplified with the index 2. And then we have A. But before that, whatever we are multiplying the denominator, we have to multiply a numerator with the same number, because square root of A divided by square root of A is 1. And 1 multiplying by any value, we get the same value. So it means we are applying the identity property of multiplication. But in the rationalizing denominators with the square roots, it's not a big problem, because we always, when we have especially as a denominator just one value, we multiply with the same value, so we are going to get in the power square, and then we just have to simplify index with the power. But the problem gets a little bit more nasty when we have, for example, cubics, like in example B here, and we have 2x. But because it's a cubic, then this radicand, I'm trying to find the same value, that when I multiply numerator and denominator, this denominator is going to get in the power 3. Both values, numerical value 2 and the variable x, are going to be in the power 3. And for example, in order for me or for us to make this cubic, 2 cubic, and x cubic, we have, for example, 2 to multiply by 2 square, and it's going to be 2 cubic. So 2 square times 2 in 1 is 2 cubic. And then this x square times x is going to be x cubic. And whatever multiply denominator, we multiply with the same value, the numerator. And we have here 2x over 4x squared, because 2 square is 4, is a 4x squared. And now this 3, the power 3, we can simplify with the index 3 here. And what remains? Just a 2x. But because here I have 2x and here is a 2x, we can simplify 2x's, and remains just a cubic of 4x squared. So this is equal to the cubic of 4x squared. And now let's see another example when we have a little bit more complex. Let's say I have 1 over 9th root of A. And now, in order for us to rationalize the denominator, we have to find something that A I'm going to make it in A in power 9, because we want to match the power of the radicand to be the same with the index. So the power with the index is going to simplify to give us 1. For example here, 1 over 9th root of A times cubic of 9, A in 8, A in 8. So A in 8 times A in 1 is going to be A in the power 9. So we see here the power 9 here matches with the index 9, are the same. And when we have, for example, the radical form, we can write in exponential form, like A9 divided by 9, which is A in 1, or is A. And whatever we do with the denominator, we do the same thing with the numerator. So multiply numerator with numerator. So 9th root of A8 times 1 is 9th root of A8. And we just drag the same thing here. And the final result is A 9th root of A in exponent 8 divided by A.